The ideas expressed in the following presentations are those of the speakers and do not necessarily reflect the views of ACI or its committees. ACI web sessions are recorded at ACI conventions or other concrete industry events and will be made available for viewing free of charge for 1 week. Thereafter, they will be archived on the ACI website or added to ACI's online CEU program, depending on their content.
Hi, thank you all for coming. I'm going to discuss two tech notes that involve concrete removal. The first relates to concrete removal involving corroded reinforcing steel, and the other discusses the use of hydrodemolition for concrete removal in unbonded post-tension systems. So first of all, for anyone who's maybe not familiar with what the tech notes are, they're 1 to 2 page documents that are single topic guides. They're very narrowly focused. The goal is to provide direction on one specific issue, and they're typically practice-oriented. I think they're particularly useful for maybe entry-level engineers that are forced to make a decision on certain repair-related topics that they're maybe somewhat unfamiliar with. So first of all, the first tech note, concrete removal involving corroded reinforcing steel. The question is, when corroded reinforcing steel is encountered in a repair, should the bar be undercut? Which that means, should all of the existing concrete below the reinforcing bar be removed? And how far should the bar be exposed along its length? The short and sweet answer is yes, the bar should be undercut. And the amount of concrete to be removed should be at least 1/4 inch plus the dimension of your max aggregate size. So basically, all of the concrete around your reinforcing steel needs to be removed and cleaned, and the bar needs to be cleaned prior to replacing your new repair material. And also, concrete should be removed along the bar until you reach a point where corrosion products are no longer visible. These images actually come from the tech note and just help to illustrate that, yes, you do need to remove concrete around the reinforcing bar. And a little bit of discussion on why undercutting is important. When we place fresh concrete, we know that it's chloride-free and that the pH is high enough to maintain a passive layer on the reinforcing steel, which prevents corrosion. In older concrete, you may have a higher level of chloride concentration, which destroys the passive layer, leading to corrosion. Also, you can have carbonation of concrete, which reduces the pH of your concrete, then also leads to destruction of your passive layer and corrosion. If you have a repair material or a repair area where you don't undercut your reinforcing steel, you run the risk of creating an environment where the top of your reinforcing steel has a passive layer and the bottom portion is in your pre-existing concrete and it doesn't have a passive layer. This creates a electrical chemical potential difference that can effectively accelerate your corrosion and can cause accelerated corrosion around your repair area, which is called the ring effect or the halo effect, shown in this picture here, which results in delaminations and corrosion around your repair and leads to a point where you have to go back and repair your repair, which is something no one wants to do. So, in summary, when you have corroded reinforcing steel in your repair area, you definitely want to remove all of the concrete around that reinforcing and clean the bars prior to placing your repair material. And you want to make sure that your repair area is large enough to address all of the corroded steel in that area. Moving on to the second tech note, hydrodemolition for concrete removal in unbonded post-tension systems. And the question is, should hydrodemolition be used to remove concrete when unbonded post-tension systems are exposed in the removal process? And it's kind of a trick question because the answer is no. Hydrodemolition is not recommended in these types of structures, and there are Several reasons for this. Hydrodemolition in general uses very high pressure water to break up and remove concrete. These large forces could potentially lead to extreme safety issues. If your PT tendon is undercut, you could disrupt your anchor, which would result in an explosive force that could create flying debris that can damage equipment or harm workers. It's almost inevitable that by using hydrodemolition that you will damage your tendon sheathing also, which you have these massive amounts of water available too that can then travel down your tendon and could potentially lead to further durability issues related to corrosion. And also, while conducting hydrodemolition, you produce a large amount of slurry, which can also be forced down your tendon line and can build up, destroying your sheathing as well, which becomes problematic if you're also having to replace sections of your PT tendon because you're unable to then push the new tendon down the sheathing to the correct location. So, in general, engineers are not interested in specifying hydrodemolition for these types of structures, and most hydrodemolition specialists are also not really interested in performing that work. But I did speak to one specialist who gave me information on a project where they kind of use a hybrid approach. These photos are from a bank in Cleveland. It was a parking structure, and there was some issue with the top surface of the parking deck, and the engineer wanted to remove 1.5 inches across the entire deck. So they marked out the locations of the tendons prior to bringing in their hydro equipment and used hydro to remove the concrete in the areas between the PT tendons, and then used standard chipping hammers to address the PT tendon locations, which gave them greater control of the safety of the situation and prevented worry about future corrosion issues. It's not a perfect solution though, because you do run the risk of actually damaging your tendons by using chipping hammers, which is less of an issue with hydrodemolition, but you can more easily address these issues without having lots of water getting in and causing extra corrosion problems. And so, in summary, hydrodemolition is not recommended for these types of unbonded PT tendon structures, mainly due to sheathing damage that can then cause corrosion later due to water infiltration. And I'd like to just acknowledge and thank Pat Winkler, Cindy Garman, Brent Stevens, and Thano Jamalis for providing me with most of the photos that you saw in this presentation and for giving me more of a background on hydrodemolition. Any questions?
In mat slabs, where the reinforcement is very large and closely spaced, what's your position on undercutting or in lieu of undercutting, replacing with a high quality repair material and then maybe migrating corrosion or corrosion inhibitor product?
I'm not exactly sure. I would think that it would be fine. If you're worried about like the ring effect, you can also use like your sacrificial anodes and corrosion inhibitors. Yes.
You said you should undercut the bar in a 1/4 inch plus or 5 of the aggregate. I assume that's to clear the bar. But does that normally take care of the carbonation and chloride content to prevent the halo effect, or is that sufficient? Usually just undercut around the bar and that takes care of the halo effect?
I'm not exactly sure. I think that the use of sacrificial anodes is the more appropriate response for preventing the halo effect.
I could add a little bit of commentary to that if you don't mind. One of the things we do is we really look at the condition of the concrete once they've done the undercutting. Like you could actually run some pretty quick tests on the concrete, field tests on carbonation, and even on the chloride content once you've undercut it. So we use that as a guide to really decide, do we need to keep going? And I think the point of the tech note in large part is to emphasize the real need to undercut it. But then from there are other, tests that you can make to decide whether you've gone far enough with it. I don't know if that helps.
So you can run a field test on chlorides?
Correct. That's one of the things that we do. We'll run powder tests on it to just
Okay.
make sure we've gone far enough. Thanks, Rach.